Hey everybody, it's Mr. Carr again, and today we're going to be talking about 3.3 Day 1, using scale factor and similarity to determine unknown lengths in polygons and circles. We've actually already introduced this idea, so we're kind of just doing some things again. And really the main reason for that is because it leads into the next topic, okay? So on this one, we're going to first start off with identifying corresponding parts. And again, we've kind of talked about that. Given that trapezoids ABCD is similar to EHGF, identify the side that is proportional to BC. It might help to draw out the diagram. And what I'm going to do is I'm going to focus on the locations of things. A and E are in the same spot, so they're congruent to each other. B, put 2 there, is in the same spot as H. Okay, C, 1, 2, 3, same spot as G. And then D, put 1 tick mark there, same spot as F. Okay, that might be helpful to see that because then you can visualize here. BC is angles 2 and 3, just like GH. So that's my corresponding side. GH is my side that's going to be proportional to BC. Now, the other way I could have done that without marking out the diagram, so I just look at here. BC is in the middle 2 spots. Okay, so if I do that, I go BC and HG or GH are in the same spots. Okay, so it doesn't matter if I write GH or HG. They refer to the same side, it's the same thing. All right, so we're going to use that in the next step. Proportion, remember, as a comparison of equal ratios. So we're going to determine the scale factor of the missing side lengths. Scale factor is going to be really easy. The only 2 sides that I know. So I know my scale factor is 5 to 3. Okay? And so I have that set up as large over small. To find these sides, I'm going to do the same thing. Large over small. I went from this direction to this direction. It doesn't matter if I went small over large. You just need to be consistent. So if I look at that, I'm going to do x plus 6 over 3x minus 6. Okay? Now, another way I could have done that is I could have compared this leg to hypotenuse. If I did it that way, leg over hypotenuse, then I would have 5 over x plus 6, 3 over 3x minus 6. It doesn't matter again because look at what I'm going to do. I'm going to cross multiply 5 times 3x minus 6, 5 times 3x minus 6, 3 times x plus 6, 3 times x plus 6. It's the same exact work. So it does not matter, just whatever makes some more sense to you. All right, so now I'm going to do 2 distributions. 15x minus 30 equals 3x plus 18. I'll subtract 3x over, I'm going to add 30 over. So that's going to give me 15 minus 3 is 12x. That's gone, that's gone. 18 plus 30 is 48. Divide by 12, and I get x equals 4. All right, now the thing it does say is determine the scale factor and the missing side lengths. So that means I could take the 4 and plug them in here and here. So in this case, I've got 4 plus 6 is 10. Here I've got 3 times 4 minus 6. 12 minus 6 is 6. Okay, and we'll just go off of that. I don't think we need to go any further. All right. Fun fact, all circles are similar. Okay, we talk about all the side lengths being are proportional to in similar figures. That's what we talked about in 3.1. Okay, since we only have really one sort of dimension for circles, and that's the radius, doesn't matter if I have this circle or a bigger circle, they're all going to be similar to each other. So all lengths are proportional because radii and circumferences are proportional. So what is the scale factor from A to B? Well, from A is 7, to B is 5, so 7 over 5. That's it. Okay, now I don't want to call this a reduction or enlargement. That is very specific if I'm performing a dilation. This scale factor is just saying A to B. Oh, let's come back. If I said what's the scale factor of B to A, then I would say 5 to 7. Just flip it. All right, given the linear scale factor of the circles is 7 over 2, what is the value of x? Okay, 7 over 2 as the large over the small circle. So that means I'm going to set that up over here same way. large is x, 5 is small. So let's go ahead and cross multiply now. So I've got 7 times 5 equals 2 times x. 35 equals 2x. Divide by 2 and I get 17.5. There's my answer for x. Again, these are similar, so any missing radius is the same ratios as each other. All right. So quick little reflection, how you feel about this. It's not brand new from a couple days ago. So hopefully it makes pretty good sense on there. Okay. So you try now again. We'll save these for class time. All right. So that's it for 3.3 day 1. I will talk to you all later.